In this lesson, we're going to be learning how to use the magnetometer component of the SenseHat module for a Raspberry Pi. Now we're going to be using Python, and I'm going to be using a SenseHat emulator. An emulator is just a piece of software or an application that pretends to be a physical device. So you can see here that my emulator lets me do all the things that we could do with a real SenseHat. But the advantage is that you'll be able to see what's supposed to be happening on the screen, since you wouldn't be able to see my actual SenseHat with a real Raspberry Pi. But if you're following along, you would be best off to use a real Raspberry Pi and a real SenseHat device. Now, I mentioned we're going to be using Python, so I'm going to go to the Raspberry Pi icon, to the programming group, and to the Thonny Python IDE. IDE stands for Integrated Development Environment, and most IDEs provide a place where you can write code, that's up here in the Untitled window, and a place where you can see the output of your code when your program runs. So that's down here in the Shell window. Now, Python doesn't know just automatically how to talk to a SenseHat. So we have to import what's called a library. A library is code written by somebody else that's been provided to us, and it contains the statements that are necessary for doing all sorts of really interesting things that we don't then have to write the code for ourselves. So we're going to import a library that allows us to talk to a SenseHat. Now in Python, there's two ways to import. We're going to use the one that starts with from, and then the name of the library. So if you're using a real Raspberry Pi and a real SenseHat, you're going to use sense_hat, then the word import SenseHat. All right, now notice that this is all lowercase with the underscore in between. That's the name of the library. But this is written differently. This is written in what's called camel case. It starts every word with an uppercase letter, just like a camel has a hump in the middle. And so what we're saying is that from the SenseHat library, we want to import a class called SenseHat. A class is just a collection of code that provides us with some kind of behavior, maybe some state for keeping track of information. And so with this command, we're simply telling Python where to find the SenseHat class that we need to use. Now, I mentioned that I'm using an emulator, so I have to use a slightly different version of the import statement. So I'm going to import from sense_emu the class SenseHat. That's the only thing that's going to be different between my program and yours. You're going to import from SenseHat. I'm going to import from sense_emu. All right, the next thing that we need to do is to create what's called an instance of that SenseHat class. An instance of a class is called an object, and we assign objects to variables. So I'm going to start a variable called hat, and I'm going to give the variable the value SenseHat, the class, with parentheses. That says that we want to create an instance of the SenseHat class that will give us an object, and we want to assign that object to the variable hat. Now, wherever we use hat throughout the rest of the program, we're simply talking about the instance of the SenseHat that we created right here at the start of the program. All right. The next thing that we want to do is simply have Python tell us where the device is currently pointing. So I'm going to say print, that's the Python command for putting something onto the output or into the output console. I'm going to say direction, colon, and then I'm going to use %s. %s is a placeholder. Python is going to substitute the %s with an actual value when I finish this statement. I'm going to put a %. That tells Python that we're combining these things. And then I'm going to say hat, which is the instance of the SenseHat class that we declared above as a variable, and then get underscore compass. I'm going to put parentheses after get compass, and then I'm going to close the parenthesis that we started here with print. All right, so this, the dot says that we want to do something with the hat object. So from the hat object, we want to call, it's called a method, get compass. All right, this is how we get the sense hat to tell us what direction it's pointing. All right, once the sense hat tells us the direction, this is going to be a value. Then Python is going to substitute the %s placeholder with whatever that value is. And then it will take all of that and print it down here in the shell. All right, so I'm going to run the command. Oh, I have to save it first. Save my program, so I'm going to call it compass.py for Python. And I've created a directory structure in my home directory that just says inside documents I have a projects folder and a Python folder, and then within Python I have a compass folder, and then I'm calling it compass.py. You can put the program wherever you want, you can call it whatever you want, but this is a really good way to do it to keep your things organized. Alright, so when I run the program, Python is telling me that the sense hat is pointed in the 0 direction. Alright, now your sense hat, it probably is going to give you some random value between 0 and 360. Now if I go over to my emulator and I look at this yaw value, yaw represents what direction my Python my sense hat module is pointed, and you can see that it currently says it's pointed in 0 degrees. So I'm going to shift that to 30 degrees and I'm going to run my program again. All right, and now look, my direction is really close to 30 degrees, 29.998. If you turn your Raspberry Pi and your Python either to the right or to the left, you should see the number change from what it read originally to. Now, I'm going to show you here, this is yaw. All right, yaw is essentially when the Raspberry Pi is sitting flat on a surface. If you turn it to the right or turn it to the left, you are manipulating its yaw value. Okay, so you can see turning to the right, according to the arrow, increases the yaw, and then turning to the left would decrease the yaw. All right, that's the same I can do here with my slider. I can turn it way up there to 180 and run, and my direction is pretty close to 180. I can do the same thing going the other direction. Let's change it to negative 114.5 degrees and we'll run again. Oh, but wait, this was negative 114.5, but this is 245.5. Why the difference? Well, if we add the 114.5 to the 245.5, we'll get 360. And 360 is the number of degrees that exist in a circle. And on a circle, the 0 degree mark and the 360 degree mark represent the same point. So when I was at 0, I was also at 360. Now, going to the right increases the yaw. So if I move it one slot to the right, I'm at 15 degrees, or pretty close to it. But if I move it to the left, I'm at minus 15. But minus 15 also corresponds to the point 345. All right, so if I start at 0 and I go minus 15, I'm going to the left 15 degrees. But if I start at 0 and I go to the right 345 degrees, I'll be in the same place. All right, so that's how we look at my yaw value being negative numbers up to negative 180 and positive numbers up to 180. Your Raspberry Pi and Sense Hat will give you values that represent between 0 and 345 or 360, which is the yaw value turning to the right. So we've got a great start. We have our Python program telling us what the current direction or compass heading is for the Sense Hat, and we're printing that to the console. Now our program would be far more interesting if it allowed us to turn the Raspberry Pi with the Sense Hat on it and constantly update its direction. Rather than having to run the program, then turn the Raspberry Pi, and then run the program again. All right, so we're going to do that with what's called a Python loop, and we're specifically going to use what's called a while loop. Now, I'm going to go just above the command that prints the direction. And I'm going to put in a new line, so I just pressed enter, and I'm going to say while true, and true is a capitalized word, and then colon. All right, colon in Python denotes what's called the start of a block. All right, so while is going to take a series of commands. It can be one command, it can be more than one command, and they're going to be set off or started. So everything following the colon belongs to this while loop, but I have to tell it which commands I want to include in the while loop by indenting the commands. So I'm going to put one tab. All right, that's important. So this is a tab. So what Python says is that while a value is true, in this case this loop will run forever, the colon says everything following while true that is indented one tab stop is part of this while loop. So while true colon print direction, and then substitute the placeholder with the current compass reading. Now, since that's the only command I want inside the while loop, that's all I have to do. Python will go to the while loop. It'll say, oh, while true, run forever, print the current heading, and then go back up to while true. Well, true is still true, so we'll do it again. And then we'll go back, and true is still true, and do it again. Okay, now we're going to break out of this program with a Control C. So you're going to hold Control and press C when you're ready for the program to quit. So I'm going to run the program, and you see now it's printing the same value just over and over again. But if I go to my emulator and I turn the yaw, the values change. And if you take your Raspberry Pi and turn it right or left, sitting on top of the desk or whatever other surface it's sitting on, these values should change for you too. As you turn to the right, they should get bigger. And as you turn to the left, they should get smaller. If you go past 0 or 360 degrees, you should get values starting at 360 degrees moving downward again. If I drag it, I can come up with more interesting values than just 15-degree increments. Just like your rotation is not going to be even increments either. All right, so that's far, far, far better than just having to run the program over and over again to get a new direction. Now we have it doing it forever, essentially. This is called an infinite loop. Now, like I said, if you want to break out of the program or quit the program from running, you want to hold down the Control key on your keyboard and press C. All right, and that will print this somewhat ugly message here at the bottom that says there was a problem. That's normal, nothing to be concerned about. We're going to deal with this in a later segment by handling this keyboard interrupt. All right, the next thing that we want to do, most compasses are circles, which is a pretty reasonable representation since they're using degrees from north to represent a direction. So I'd like to put a circle on the LED display. And then on that circle, we'll draw what the direction that the SenseHat is detecting. So to do a circle, we're going to use two new concepts in Python. One is called a list, or sometimes it's called an array, and the other is called a tuple. So we're going to create a new variable. I'm going to call it circle, because that's basically what it represents, and my circle is going to be a Python list. Again, that's also called an array. So lists in Python are set off or denoted by square brackets. So I'm going to have circle, which is a new variable. Circle is given the value empty array or empty list. Now inside that list I need to put the values. Now, I want to draw a circle that goes kind of along the outside edge, so I'm going to go 4 pixels across the top of my LED matrix and then down 1, and then 4 pixels down the side and then over 1, and then 4 pixels across the bottom and up 1, and 4 pixels across the side and up 1 again. Okay, so when I'm done, I'm going to end up with white, 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 white. It'll all look kind of like a circle. It'll be a little rough, a little jagged because I've only got 64 squares to work with, but that's going to give me a frame essentially to draw my direction on. Okay, so we started our empty list called circle, and now in that we need to pick a starting point. So I'm going to make this one here. It's just right of center at the top of my sense hat. That's going to be my my 0 point. Okay, now we have to figure out how to identify this 0 point. Now, the sense hat LED matrix is a square made up of 8 LEDs going across and 8 LEDs going down. Okay, now each LED has a unique address based on where it is from the upper left corner going to the right and going down. But the thing that's kind of tricky is that the upper left corner is the point 0, 0. So it basically says that starting from the upper left corner, I've moved 0 positions to the right and 0 positions down. And that leaves me here at the upper left corner. Now, if I move 1 position to the right, my location is 1 right, 0 down, and then 2 right, 0 down, 3 right, 0 down, 4 right, 0 down. Okay, so I want to create what's called an ordered pair, which in Python can be represented with a tuple. And my ordered pair is going to be the position of every pixel that I want to light up. So again, starting with 0, 0, move 1 right, 2 right, 3 right, 4 right, and 0 down. So that's my first tuple. Tuples are indicated by parentheses or curved brackets. Okay, so 4, 0 represents this point right here. If I go 1 more to the right, I'm at 5 right and 0 down. So I'm going to call that point 5, 0. Now, when I get to 6 right, I don't want it to be on the 0 row. I want it to be on the 1 row. So I want to go 1 right, 1 down. So that's going to put me at 6, which would be 1 right of 5, and 1, which is 1 down from 0. Now, just to make sure that I'm kind of on the right track, I'm going to introduce something that will actually draw this circle on the LED matrix for me. Now, we already used a while loop in Python. Python also has what's called a for loop. So for, and what are these things that are part of our circle? Well, they're kind of like points. They're the points on the circle that we want to draw. So I'm going to say point in circle. Okay, so this is my circle list, and it has the point 4, 0, 5, 0, and 6, 1 right now in it. So in my list circle, for every point and colon, just like the while loop, we have to create a block, and we have to indent the next statement to say that it's part of that block. Now, my hat has another command. Just like get compass was a method, it has another method called set pixel, P-I-X-E-L, and it takes an x coordinate, or how far to the right, and a y coordinate, which is how far down. Well, conveniently, that's what we stored in our point tuple. This is how far right, so that's our x, and this is how far down, that's our y. So what I want to do is say that every time through my loop, point is going to get a value from the list, and the first time through it's going to get the first value from the list. So when I first start this for loop, I'm going to start at the tuple 4, 0. That's going to be assigned to the point variable. Now, to get the first value out of that tuple, I have to use what's called an indexing command. All right, so that's a square bracket as well. So I'm going to say that I want the 0th index, or the first item. Now, just like starting over here, counting squares across our SenseHat matrix, arrays and lists in Python start with the first element being the index 0. So this tells me that from the point tuple, which is the first element on my circle list, I want to get the first value, which is the 0 index, and that'll give me the 4. And then for the y, it's going to be the 1 value of that tuple. All right, so this is the 0 position, this is the 1 position. Then lastly, I have to tell it that I want to set it to a particular color. Now I'm going to call the color white, so that'll make me a white circle. And then up here above circle, I have to define the value white. Now, colors with the SenseHat are also defined in tuples, but in this case the tuple has 3 elements, not just 2. So I have to start another tuple with parentheses or curved braces. And then the 3 values I want to use are a value for the red component, the green component, and the blue component. And those values are specified from 0 to 255. Now, white happens to have the value 255, 255, 255. Excuse me. Black, on the other hand, has the value 0, 0, 0. Okay, so I'm going to tell Python that I want white, the variable white, to have the value of a tuple with 3 components, each of which has 255 as its value. And then the setPixel command is going to interpret that white as red equal to 255, green equal to 255, and blue equal to 255, and that's going to actually generate a white color. All right, so once we have all of this coded, again, we're just checking to see whether we're on the right track with our circle. I'm going to save it, and then I'm going to run it, and you see that the 40 pixel lit up, the 50 pixel lit up, and the 61 pixel lit up. That's perfect. That's exactly what we wanted. Now we just need to finish our way around the circle. So back over here in Thonny, I'm going to hit Control-C. That's going to quit my program. And now all I have to do is finish typing out my definitions. Okay, so from 6.1, I'm going to go right 1, down 1. That's going to put me at 7.2. And then the next point from 7.2 is actually just down 1. I don't have any farther right to go, so it's going to be 7.3. And then from 7.3, it's just down 1 again to 7.4. And down 1 again to 7.5. Okay, so 7.5 gets me to here. Now, the next one I want is down 1, left 1. So I know my y value is going to increase by 1. I'm going to go from 5 to 6, but my x value is going to go from 7 back to 6. So moving to the right increases the x, but moving to the left decreases the x. So now this is going to be 6, 6. And then last row down here, I'm from 6, 6. I'm going to go down 1, left 1 again. So left 1x is 5, down 1y is 7. That puts me here. And then one more left, but no more down. So I'm going to decrease x by 1, so I'm going to be at 4, 7. Now, I'm going to test again right here. It's always good to test periodically to make sure that things are progressing the way that you think they are, so that you can solve any problems that might have come up before you got there. Now, I didn't mention, but this is important, all of the individual tuples are separated with commas, and that's how Python treats the individual elements of a list. So we have a circle that's a list of points where every point is a tuple, and those points are separated in the list by commas. Okay, now the last element does not have a comma because there's no more, so there's nothing to separate it from. So right now this should draw half my circle. So if I run it, there we go. It's gone all the way halfway around the LED. Okay, Control C again. We'll quit the program and I just need to finish my circle. Okay, so now I need to hit a comma, I need to insert a comma after that last element. And I'm going to put it on a new line. That just makes it easier to read. Python really doesn't care whether all of these elements are on one line or on 8 lines or on 20 lines. It doesn't matter because it knows where it starts with the square bracket and it knows where it ends with the square bracket. It knows how to separate elements. Those are with commas. And then within each tuple, it knows that the tuple is started with a parenthesis, ended with a parenthesis, and has values separated by commas. Okay, so going back to the point 47 where we're going to go left 1, but down 0. So left 1 from 47 is 3, 7. Then I'm going to go left again. That's 2, 7, because I still didn't drop down. But when I get to 2, 7, the next point left is up 1. So I want to go left and up from 2, 7. So left 1 is the 1 on the X, and up 1 is 6 on the Y. So 1, 6. And then from 1, 6, I want to go up 1, left 1. So that's going to be 0, 5. And then once I'm at 0, 5, it's just up to 0, 4. And then up again to 0, 3. And then up again to 0, 2. All right. The next point from 0, 2 is right 1, up 1. So that's a 1 more x, so 1 increase x by 1, and decrease y by 1. That puts me at 1, 1. And then I just have 2 more points to go. That's 0, 2, so up 1y, right 1x, or right 1x, up 1y, and then right 1x and up 0y. Whoops, sorry, I got this one backwards. This should be 2 because that's where the x is. So I was at 1, 1. I moved right 1, that puts me in 2, and up 1, that puts me at 0. And then here I would be right of 2, 0, which is 3, 0. And that should be the last one. Now, because it's the last element, I don't put a last comma, but I run it, and now my circle is complete. I've drawn a circle all the way around the frame of the SenseHat LED matrix, and we're next going to put a color on this circle to indicate where the SenseHat is pointing. Now you might have noticed that when you hit Control C to stop the program from running after we completed the circle, that it leaves the circle outline on the SenseHat LED matrix. It would be really nice if we could clean up after ourselves, if we could clear the matrix after we're done running our program. So that's what we're going to do now. Now, that's also going to take care of this output down here in our shell window. Now, to do this, you can see that Python has reported this thing called a keyboard interrupt. Well, we have to catch or trap that interrupt in order to know when the user has pressed Control C. And to do that in Python, we use what's called a try except block. So this is a little bit complicated. It's a little bit kind of advanced Python, so we're not going to go into too deep of detail with this try except block, but I am going to show you how to use it. All right, so the first thing we're going to do is say try. That's going to be inside our while true loop, and you see it's indented one place because it's the statement that belongs to while true. But try itself also takes a block or needs to be followed by a block. So I'm going to say try colon to indicate that there's a block of statements I want to execute that are part of the try section. And then I'm going to indent the print command a second tab stop. Okay, so now this is one tab stop to get to try, and then one more tab stop to get to print. And what that says is that inside try, everything that's at the same level as this print statement is going to be executed up here. And then when an exception occurs, that's keyboard interrupt is a type of exception, then it's going to break out of the try and go to the except block. Now, try and except are paired up, so they're at the same level. And I have to say what kind of exception I want. So I want the keyboard interrupt exception, and that needs a block, so I'm going to hit a colon there. And then I want to clean up after myself. So I want hat dot clear. That's the command to clear the LED matrix of the sense hat. And then I need one more thing. I need to tell Python that I'm finished. So I'm going to call sys exit. Now the problem is that Python doesn't know yet what sys is. Sys is something else I have to import. And I have to import it differently than the way I imported the sense hat library. So I'm going to use the second import type command from Python. It's called import. And I just need to import sys. Okay, so I'm going to put that at the top. And now this tells Python that in addition to the sense hat or the sense emu, we also need to import a library called sys. And then from sys, we're going to use the command called exit. Okay, now if we go back up and look at our while loop, all of this is indented. Okay, so all the try and the except both belong to the while true block because they're indented at the same level. But everything that belongs to try and everything that belongs to except is also part of what belongs inside the while true block. Okay, so now try colon says that only the print command is part of try. But if while we're in here in the try part, if the user hits Control C to quit, it's going to generate this keyboard exception or a keyboard interrupt, which we're going to trap with this except block. All right, and that's going to tell us to say clear the sense hat display and quit the program. That's what sys.exit does. It quits the program. So let's save that. Let's run our code again. You can see we're still getting the direction. We've still got our circle. But now when I hit Control C, it cleans up after itself. It executes the clear command on the sense hat. It tells Python that we're finished, which calls sys exit, which exits the while true loop, the infinite loop that we created. And you see that we no longer have that what's essentially an error message down here in our shell. This is a more a nicer way to exit our program, or a cleaner way to exit our program. We clean up after ourselves and then we tell Python that we're finished. So we're making really great progress on our program. But now we're going to do the really interesting part. We're going to put a red dot on our circle that indicates where north is. That would be just like a real compass. A magnet always points north, so a compass that's based on a magnet also points north. So what I want to do here, I'm going to make some changes. I'm going to make them all within or inside of this try except part. So inside the block that belongs to the try, I'm going to highlight the hat.get underscore compass with the parentheses part, and I'm going to hit Control X to cut that particular statement. And I'm going to replace it with the word direction. Now, just above that line, I'm going to say that direction, that's a new variable called direction, is equal to, and then Control V to paste in the hat.get compass part. Okay, so this is exactly the same code as before. The only difference is that I have separated the assignment of a variable direction from the use of that value that got assigned to direction. So instead of calling get compass directly inside the print statement, I'm now calling get compass and assigning it to a variable so that I can use the variable later. If I save that and run it, you can see that there's no change. I'm still getting a direction that's updating constantly, I've still got my white circle drawn around my SenseHat LED. Okay, so it didn't change the code at all, or it didn't change the function at all. It just moved me one step towards the next thing I need to do, which is I'm going to need to use the value of direction in a calculation. All right, so I now need to find out how far away from north I am. So I'm going to say north equals, and north should be the top of my circle. And we said earlier that the top of the circle is both 0 and 360 degrees. So as long as we're close to either 0 or 360, we should be pointing straight up. But as we move farther around, we're going to get farther and farther away from 360 until we get to the other side of the circle, where continuing around we start to get closer to 360 again. So I'm going to use a calculation like this. 360 minus direction is going to tell me how far around the circle I am. Now if we think about it, when we're at 0, 360 minus 0 is 360, and we said that's the top. But likewise, when I'm at 360, which is also at the top, 360 minus 360 is 0, which is the top. If I go halfway around, I'll be pointing at 180. 360 minus 180 is 180, and so that's going to put me halfway around the circle. All right, so just to kind of check myself, I'm going to put in another print statement. But instead of direction, this time I'm going to use the word north. I'm still putting in a placeholder, and then I'm going to put in north. Okay, so this is going to tell Python to print both the direction and the calculation that says how far we are from north. Okay, so now you see we have both values, 305.5, 54.5. If I add those two together, I get 360. Okay. All right. The next thing I want to do is I've got to figure out which of my pixels needs to light up. Okay, now my circle has 20 pixels on it, but this calculation assumes that we're on a circle that has 360 points on it. There are 360 possible values that I could get assigned to north, but I have to figure out how to assign one of those 360 possible values to only 20 possible values. So to do that, typically when we want to change a value from one set of units into a different set of units, we use what's called a proportion. So to use a proportion, I have to first convert the value in the first set of units to a fractional part. So I'm going to take north, and north represents one of 360 possible values. So to know the fractional component, I divide it by 360. That's how many parts I could have. All right, so this tells me in fractional terms how far around the circle I am. And then next I need to I need to figure out which of the 20 parts of my available circle I want to light up. So I'm going to multiply by 20. All right. The problem here is that north now can have a value between 0 and 360. So when I divide this, I'm going to get 0 to 1. Okay. When I multiply that by the 20, I'm going to get 0 to 20. All right, because if north is 0, then my pixel value would be 0. If north is 360, this fractional part is 1. Multiply 1 by 20, I get 20. But remember I said that lists start with index 0. So this 40 point is actually element 0 inside the circle list. All right, that means that this last point is not position 20, it's only position 19. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so I don't want to use 20. I actually want to use 19 because that's how many possible elements there are, or at least the indices that I can use. It would also be better if I let Python determine how many elements there are instead of telling Python that there are 20. That way, if I someday came up with better equipment and my circle had more than 20 points on it, and I put more than 20 values in my circle list, I wouldn't also have to come down here and remember to change this 20. So I'm going to use a Python function called length, and I want to find the length of the circle list. Okay, so this is going to tell me how many elements there are in the circle list, which will be 20 based on my current list. But I'm going to take one away because the indices for that list can only be 0 to 19. Okay, so now instead of multiplying the fractional part of the circle by 20, I'm going to multiply by 19. That's going to give me values that range from 0, because when north is 0, 0 divided by 360 is 0, times 19 will give me 0. But when north is 360, then this is going to give me 1. North 360 divided by 360 is 1, times 19 will be 19. So now I can use pixel as an index into circle, or to tell me which of the points in the circle list that I want to light up. So let's print the pixel value. Just like we've done before, just replacing the label with pixel. We still have the placeholder, and then the value that's to be replaced is pixel. And if I run that, it's now telling me, oh, that it's 16.12. Well, I'd really like for this to be, an even number, a whole number, instead of a number with a fractional component. Well, Python lets us do that too with a command called round. Okay, so round is going to say take the calculation and then round it off to the nearest integer value, or the nearest whole number value. So if I run it again, now my pixel values are whole integers, and as I'm moving around the circle, my pixel values are changing. It's telling me which pixel needs to light up. All right, now once we get there, lighting it up is actually very, very easy. So just like up here, we used the hat set pixel, and we needed to know what pixel, and from the pixel we were going to get the 0 and the 1 components, or the x and the y components, and what color we want. All right, now we had a color for white. Let's make a color for red. Now red, if you'll remember, white was 255 of red, 255 of green, and 255 of blue. Well, red should just be the red part. So red is 255 of red, no blue, no green, and no blue. So that should give me a color that is red. So now I want to say hat set pixel. Pixel tells me which element of the circle, because this is going to be a value from 0 to 19. So if it's 0, I want the pixel, or the 0.40. But if it's 9, I want the pixel 47. All right, so to get that, I'm going to use pixel as an index into circle, like that. Okay, so now circle at element pixel, 0 would give me the value 40, 9 would give me the value 47. All right, but the first part of set pixel is just the first part of the point. So I take whatever circle at element pixel gives me and take the first value. Then I want to take the circle at element pixel and get the second value, or the value whose index is 1. So the first value from the tuple has index 0, the second value from the tuple has index 1, and then I want to color all of that red. Now if I run it, you can see that there is north. And if I turn, now in my case, it's continuing to turn, but it's also lighting up more than one pixel. Well, that's because it's remembering where the last pixel was, and it's not recoloring it. It's just coloring the new pixel red. So every time we color a pixel red, we also need to color a pixel white to go back to the previous value. Now, in order to do that, I have to keep track of where the last pixel was. So I'm going to start just by assuming that the last pixel was at 0. Okay, so I'm going to say last pixel. I'm going to set a value last pixel to 0. And then before I set the new pixel to red, I want to set the last pixel to white. And I'm going to use the same structure that I've used here, used to set the new pixel, but instead of using pixel, I'm going to use last pixel. Sorry, that was not very good typing on my part. All right, so what we're doing here is every time we go to paint a new pixel, we first need to paint the old pixel, the one that was red. We need to paint it white. And we're going to start with just assuming that it was at 0. It doesn't matter because 0 is going to be white to begin with anyway. We're just going to paint it white again. All right, but then after we've painted the new pixel red, we need to save, oops, didn't realize I mistyped that, sorry. We need to save the value of the new pixel as the last pixel so that the next time through the loop, Python will first paint that last pixel white again before painting the new pixel red. Now, if it happens that the sense hat hasn't rotated, it doesn't matter. We'll paint it white and then very quickly paint it red again. All right, so we'll just constantly alternate between white and red. But if the value is different than it was the last time, then we'll paint the last pixel, which was red, we'll turn it white. And then we'll paint the new pixel red. But then we have to save the new value in as the old value. So last pixel now equals pixel. And that means that when I go back up to the start of my loop, last pixel has the value of the pixel that was last painted red. And when I get down to this line, I'm going to change that pixel back to white before I paint whatever the new pixel should be red. All right, so if I run that, you see that now as I turn my sense hat, only one pixel lights up red, and that's the current location of north. Now, as you're turning your sense hat, your red dot should basically be staying pretty much in the same location with the sense hat rotating kind of around it or underneath it. It's a little hard to tell with mine since my sense hat doesn't rotate. My dot rotates. But as you're turning your device, your red dot should stay pretty much in the same spot. Now, the last thing that I think we want to do, it would be really nice if the sense hat could tell us where up is, or where the direction that it was originally facing was. So if we think about that in terms of our circle, that's essentially one of these two pixels. All right, so this represents the top of my circle, and as I'm turning my sense hat, I'd kind of like to know where this is. So if I could put a dot on that pixel that was in a different color, as I rotate my sense hat, the dot will rotate in a fixed position, but then the red dot, which indicates north, will float around the circle. So to do that, what we're going to do is change the last pixel color. Okay, so it's white most of the time. All right, but there's one particular spot where I want it to be a different color. Okay, so I'm going to make a new color. Go back up here where my colors are, and I'm going to make a blue color. So that's no red, no green, and full blue. So 0, 0, and 255. The 255 is the blue component. Then in this spot right here, just above the place where we're setting the last pixel color, if the last pixel is the 0 element of the circle. Now, I need to explain, in Python and most programming languages, when you want to check to see that something's equal to another value, you use two equal signs. All right, it's not true for all programming languages, but a lot of them do use double equal signs to mean check that the value is equal to. Single equal signs are used to assign values, but double equal sign are often used to check values. So what I'm asking here, it's an if statement in Python. I'm saying if the last pixel is the 0 index to our circle, which would be this position here, the point at 4, 0, then I want to paint it blue. So I'm going to create a new variable called clear color. That's the value I want the last pixel to be cleared to. And if the last pixel is 0, or the 0 element of our circle, I want the pixel to be painted blue. But if it's any other position on our circle, that's the else value of an if else, I want the clear color to be white. All right, so as we can see, last pixel starts at 0, so the first time through the loop, last pixel will be equal to 0, and clear color will be set to blue. Else, or otherwise, clear color will be set to white. And then instead of telling it white, I want it set clear color. Okay, so now it's going to paint the last pixel in whatever color clear color is currently assigned to. So first time through the loop, last pixel has the value 0, then clear color will be set to blue, and then the last pixel will be painted blue. Then we'll set the new pixel to red and assign last pixel to pixel. So let's assume for the moment that the new pixel is somewhere over here. All right, so when we set last pixel to pixel, last pixel is no longer going to be 0, because as long as it's anything except that pixel right there, it's not 0. So when I come back through my loop, it goes to the if statement. It says if last pixel is equal to 0, since I set it to a different value, it won't be 0 anymore. I won't use blue. Instead, I will use white. And then when I get to this statement, clear color has the value white. So if I run it now, you can see there's up on my sense hat, but there's where I'm currently facing, or where north currently is. And as I rotate, my red dot moves, but my blue dot does not. So for you, as you're turning your sense hat in different directions, your blue will rotate to the new position as you're turning your device, but your red will always be pointing to the north, just like with a real compass.